Hello guys, my name is Bapi Ahmed and welcome to my YouTube channel. So guys, in this video I'll show you how we can perform helmet detection with the help of YOLO11. So if you don't know, YOLO11 is a computer vision model. With the help of that we can perform object detection, image segmentation, key point detection, image classification and oriented bounding box. So here's the notebook guys I prepared helmet detection using YOLO11. So first of all you have to connect this notebook with your GPU. So let me connect. So this is my GPU and I'll try to connect. See, here we'll be fine-tuning one pre-10 YOLO11 model. So that's why we need a GPU here. So let me reconnect the notebook. And all the resources would be available in the description section. From there you can download. And you can see the YOLO11 model view. So it is available in the alternatives. So if you open the alternatives, so you'll see that YOLO11 is available and all kinds of models are also available. Now you can use any kinds of model as per your requirement. So my notebook is connected. Now let me just check whether I got GPU or not. So this is the GPU I got. Okay, the first thing guys, what I have to do, I have to set up the Alterytics package, because if I want to use YOLO11, I have to install this particular package. And in my previous tutorial, I already explained, okay, how to set up the Alterytics, how to do the custom training and all, everything I try to clarify. Now, if you want to check the version of the Alterytics and the environment version and all, you can execute this command. Let's say you want to set up this thing in your local machine. Okay, that time, what will be the Python version? What will be the, let's say, package version? If you're using GPUs, what will be the GPU configuration? That means what is the CUDA version and all, everything it will show you. Okay, then let me import the YOLO and image function. Okay, because I need it. Now we'll be downloading the data. Now you can ask me where we'll get the data. Data is available inside RoboFlow universe. So RoboFlow is one amazing platform. So it will give you all kinds of computer vision related tools and technology. So it is having one amazing product called Universe. So inside Universe, actually, we're having all kinds of computer vision related data. Let's say you want to perform object detection, classification, segmentation, key point detection, all kinds of data are available. Now let's say I want to perform helmet detection. Simply search for helmet detection. Okay. So you'll see different kinds of helmet detection data would be available. Okay. Now here I will be using this particular data, guys. You can see helmet detection computer vision project, this data. And if I show you the label, so this data is having actually multiple classes like cycling helmet, half face, then helmet, then hard hat, then helmet, then a modular helmet, motorbike, okay, motorcycle, no helmet. Okay, so these are the actually classes we are having. You can see this is the image. Okay, so if I open up any kinds of image, you can see that. See, this is the image. So now if I want to get the data from the RoboFlow, guys, what I have to do, I have to click on the project. So there is a download option is there. Now I'll be selecting the YOLO11 format, okay, because we'll be using YOLO11 and this data is already annotated. You don't need to annotate it. Okay, it is already annotated. Now let me click on continue, select the code and continue. We'll be downloading with the help of code snippet. Okay, so copy the code and just try to paste here. Now if I execute, it will automatically download the data from the RoboFlow universe. Now see guys, this data is available. You can see inside the folder and data.yaml file is there. Now see guys, it is having 13 classes and all the classes list you can see. Now only you just need to change the folder location. So let me change. So I'll open the train, copy the path and try to replace this folder. Also I will do it for my validation, then testing. Okay, now let me save and now we can start the training. So you can see the data location. Okay, now this is the training command. So task is equal to detect, I want to perform, model mode is equal to train, data location, YAML file, and I'll be using nano model. Okay, and epoch, let's train 50 epoch as of now. You can also increase the size as per your requirement. Let's say you need a good model, you can increase the epoch size. And image size 640 because during training actually they use this particular size. Okay, that's why we are giving. Now let me start the training. So first of all, it will download the model, that YOLO11N model. After that, it will load that data. Then it will start the training. Okay, so you can see one option is coming, enter your choice. So it is telling you, do you want to connect 1 dB? So I'll tell no, I don't want to connect the 1 dB. So here what I'll do, I'll just give 3 here. Okay, because you can see 3 don't visualize my result. So guys, as you can see, my training has started. So training will take time. So what I will do, I'll pause the video. Once training is completed, that time I'll come back. So guys, as you can see, my training is completed and it has saved all the artifacts inside this runs folder. If I open the detect train inside weight, actually you are having the weight. Okay, the model actually we have trained. Apart from that, these are some evaluation metrics it has also saved. Now let me plot some of the graph and let me show you. So this is the multi-class confusion metrics you can see. And this is the level, like how many level you are having in this data. So see guys, I think very less you are having no helmet. Okay. Then if I show you the results, that means the losses and MAP score. This is the graph. You can see loss is decreasing as per epochs is increasing and accuracy is increasing as per epochs is increasing. That means it's learning better. Now you can see some batch images as well. Yeah, so you can see some batch images. Okay. Okay, now let's do some inference operation, guys. So here you can see I'm giving my model. The model actually I have trained. So this is the model location. Let's try to copy this base.pt path. Okay. And just pass it here. This is my model location. And this is my data. That means I'm giving my test images. Okay, test image sources. I want to see all of the test images detection. You can also pass single image. I'll also tell you. Let me first of all execute. See, in the runs folder, it will create another folder called predict. Inside that, it will save all of the images. Around 568 images we are having. Now see, these are my detection. Okay, you can see this is a sports helmet. 98% my model is confident. Now, if you want to plot them, you can also execute this code. It will pick some of the detection. It will show you here. Okay, see. So here you can see cycling helmet, and this is the half face helmet. Okay, half face helmet. Then this is also half face helmet. Okay. Okay, now if you want to perform on a single image, so what you can do, just try to upload your image. Let's say this one image actually I'm having. You can also rename it. Let's say helmet JPG. Now I can copy the path and here you have to give the image URL. So here I can give helmet dot jpg. Okay, now see if I execute. So now if I open the runs folder inside detect, it has created another predictive folder and this is the results. Let me also visualize it. Okay, see, it's a nutshell helmet. That means my model is working well. And if you are having any video, guys, so you can execute this command. So here you only need to give the video, okay, video source. And if you want to use the camera, at that time you have to give the 0 here. And whenever you're using camera, make sure you're running from your local machine because Colab can't access your camera. Okay. So yes, guys, this is how actually we can perform the like helmet detection. Not really helmet detection, you can perform any kinds of detection, okay, with the help of this technique. And you can use this YOLO11 model. It's one of the amazing model they have trained. So yes, guys, this is all about from this video. I hope you liked it. So thank you so much.